We are going to do a very important and a very interesting sum. Let's see this sum first. It says that in the given figure, we have ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, so AD and BC intersect at O, then show that area of triangle ABC upon area of triangle DBC is equal to AO upon DO. Now when we look at this to prove, what do we want? We want the ratio of the areas of the triangles. Now when we are talking about area of a triangle, we know the formula for area of a triangle. It is half into base into height. That means you are talking about the base and the height here. If you observe these two triangles, do they have a common side between them? Yes, they have a common side. What is that? Yes, it is BC, right? So now in this triangle ABC, for BC to be the base, the height will be from where? It has to be from A. Beautiful. So from A, we need to draw a perpendicular so that we get a height. Do we have it? No. So we are going to construct it. So now we have draw AL perpendicular to BC, right? Now the next one, in the next triangle which we saw, that is in triangle DBC. For BC to be the base, height will be drawn from where? It has to be from D. So from D we draw a perpendicular on BC, and that is the next construction where I draw DM perpendicular to BC. So this is what we thought about the construction, right? Now why did we do this? Because we want area of a triangle. So students, we're going to consider area of triangle ABC upon area of triangle DBC. So for that, first, what is area of triangle ABC? It is half into base into height. That means it is half into BC into AL. Same way, what's the next? What is area of triangle DBC? It is half into BC into DM. Is this much clear? So we got the areas of both the triangles. Now what do we do here? What gets cancelled? Half and half gets cancelled. BC and BC gets cancelled. So what do we get? We get area of triangle ABC upon area of triangle DBC is equal to AL upon DM, right? And let's say this is going to be our result number 1. Now you'll say we got area of triangle ABC upon area of triangle DBC. We wanted the same, right? Because if you observe the left hand side of the two proof, we got the left hand side now. But now focus on the right hand side. If you see the right hand side, numerator, we want AO, and what do we have here in the numerator? We have AL. Okay, beautiful, right? Now we look at the denominator. We want DO, but what do we have here? DM in the denominator, right? That means we are saying that if we want the right hand side of the two proof, we need to prove that AO upon DO is equal to AL upon DM. This is our end result. If we get this, we are getting the proof. So now remember, we want two ratios to be equal. You know what we had learnt earlier, if you remember? Yes, what we had learnt is whenever we had two products equal, remember? We used to write them in the form of a ratio. But when we write those products in the form of a ratio, remember that the numerator should form one triangle and the denominator should form another triangle. That means now only focus on the numerator. If you focus on those numerator AO and AL, right? Check. Do they form AO and AL? Do they form one triangle? Yes, they form one triangle. Which triangle is that? It is nothing but triangle AOL, right? Which triangle? It is ALO, right? So we have this triangle. So this is one triangle, right? So that we get the numerator. Now if you look at the denominator, DO and DM, do they form one triangle? Yes, they form one triangle. Which triangle is that? It is triangle DMO. That means these are the two triangles which we need to prove similar, because if we get them similar, then we are getting these ratios equal. Superb. So now we have the hint. We have to prove that triangle ALO is similar to triangle DMO. Now this is what we need to get in the sum. So is this much clear to everybody? Simple, right? Too easy. So we have to prove triangle ALO similar to triangle DMO. Now look at these two triangles. Now observe these two triangles here. In both the triangles, if you observe, right, we have already got, right, one angle each, one pair of angle in both to be congruent. Why are they equal? Because we know that each of them is 90 degree. And where did we get the 90 degree from? From the construction, right? So we can write there each is 90 degree and the reason is construction, right? Beautiful. Can we have one more pair of angle congruent there? equal there? Yes, we have them. What can we say about this angle AOL and angle DOM? They are equal. Why? Vertically opposite angles. So we write there, therefore angle AOL is equal to angle DOM. Why? Vertically opposite angles. So now the question is, what can you say about these two triangles? Are they similar to each other? Yes. By which criterion? It is by AA criterion of similarity. So we write there that these two triangles, that is triangle ALO, is similar to triangle DMO by AA similarity criterion. So we got the triangles to be similar. Now if the triangles are similar, now we are going to take what we want. So we wanted that ratio. Right now we take that ratio, that is AO upon, so what is the corresponding side of AO? It is going to be DO. Beautiful. So AO upon DO will be equal to what we wanted. It is AL. What is the corresponding side for AL? It is going to be DM. Right. So we write it is equal to AL upon DM. Now, what is the reason for that? It's corresponding sides of similar triangles. Now once we get this, we just substitute this value, what we got in result number 2, in that result number 1. So we do that, substitute that. So now what do we get? We get area of triangle ABC upon area of triangle DBC is equal to AO upon DO, and we got this from 1 and 2, and that's our proof. Wasn't that easy? A very simple proof, right?